This is an explanation of Chapter 6, Section 3, Number 2 for University of Phoenix's Math 213 class. The problem says use a rectangular region to illustrate each of the following products. Number 2a, the problem is 1/3 times 3/4. We did a little explanation from problem 1, if you watched that video, that if we start with the first 1/3, we could use that as the number of rows in a unit rectangle. So I'm going to go ahead and make a rectangle. And if I think of 1/3, I think of that as being one row out of 3 being shaded. So the first thing I'm going to do is make 3 rows. And I'm going to go ahead and shade one of those 3 rows. Doesn't matter which one you shade. 1/3. So this across shows 1 out of 3 equal size sections. These should be equal. Not perfect in my drawing, but you get the idea. 1 out of 3 equal size sections. 1/3. Now I like to think about multiplication problems as 1/3 of 3/4. My favorite context in this type of problem for this picture is that I have 1/3 of a pan of brownies left after a party, and my daughter eats 3/4 of what's left. Well, this is the only part that's left. If I need to figure out what's 3/4 of that, I'm going to have to go the other direction. So we did 1/3, we dealt with rows. Now we're going to talk about columns representing 3/4. So to represent 3/4 in columns, of course I'm going to have to split this up into 4 equal size columns. And I'm going to shade 3 of those columns. 1, 2, 3. Now what part are we talking about for our answer? Well, if you think back to our context of there was only 1/3 of a pan of brownies left, and my daughter ate 3/4. Here, four sections here, and she ate 1, 2, 3/4 of what was left. This is all she ate, this part right here. So she ate 3 sections, or 3 parts. And if I wanted to know how much of the total pan of brownies she ate, then I would say she ate 3 parts out of, well, each of those parts are the same size parts. For the whole pan I'd have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She ate 3/12. That's the most accurate answer for this problem. But if I wanted to reduce it to think about what that meant, I could reduce that to be 1/4. So she ate 3/4 of the 1/3 that was left, and that turns out to be 1/4 of the whole pan of brownies. So let's try a similar problem for B. The problem for B is 2/3 times 1/5. Stick to the same procedure as last time. I'm going to make my rectangle. I like to have the first numbers being my rows, so this would be 2/3. So I need 3 rows. I'm going to go ahead and shade 2 of those 3. Then my columns, I'm going to represent that as 1/5. So I want to break that into 5 equal columns. Again, mine are probably not equal, but you get the idea. And we're just going to shade one of them. Doesn't matter which one. It could be in the middle, first one, doesn't make any difference. We're thinking about that same brownie problem, so we want to know if there was 2/3 of a pan of brownies left, and I ate 1/5 of what was left, I'd be eating this part, this overlap part. So how much of the whole pan did I eat? Well, I ate 2 parts, that's for sure. So 2 parts out of how many total of those equal sized parts are there in the whole pan? Well, there's 1, 2, 3, 4, 5 across, 3 down, 5, 10, 15. There should be 15 total sections. So I ate 2 out of 15. And there's no way to reduce that. So my final answer there would be 2/15.